Hi, this is Mrs. Wiederholt, and welcome to my lesson video on graphing rational functions. Now let's get started. First, let's look at the parent function. Right here, we have y equals 1 over x, or 1 divided by x. And this parent function can be transformed into looking like this type of function. So let's look at the values that can transform our parent function. First, there is the a value, and it determines the stretch or the steepness of the function. Also, the sign of a determines the direction of the curve. So now let's look at our transformed equation right here, and let's look at the position of a. A is going to be in the numerator. Now again, this will determine how steep or how flat our function is, or our curve is. It will also determine if it's negative or not. It will determine the direction of the curve. Now let's look at the h value. The h value shifts the graph horizontally, and it also determines what is called the vertical asymptote, and we will learn more about that in just a few minutes. Now let's look at the k value. The k value shifts the graph vertically, and it also determines the horizontal asymptote. And again, we will learn about the horizontal asymptote in just a few minutes. Now let's look at our transformed rational equation here, and let's see, where is the k value? The k value is going to be after the fraction. The domain of a rational function is all real numbers except for the value of the vertical asymptote. Again, we'll learn more about this in just a few minutes, but other than the vertical asymptote, the domain is all real numbers. Now, along with that, the range is also all real numbers except for the horizontal asymptote. Now that we've gone over what the different values mean in a rational equation, let's look at some graphs. Now on this page, each graph contains two pairs of curves. First, let's look at the light gray curve in the first graph. Okay? In fact, the light gray curve in each graph represents the same thing. It represents the parent rational function. Now let me bring up asymptotes. Asymptotes are invisible lines that are like boundaries. This curve right here cannot cross over this horizontal boundary right here. And going upward, it cannot cross this vertical boundary. So these invisible boundaries are called asymptotes. This one is the vertical asymptote. This one is the horizontal asymptote. Now, for the parent rational function, the asymptotes have a center, or they intersect at 0, 0. That is why the parent function, you do not see plus an h value or plus a k value. So now looking back at this first graph, and we see that our asymptotes intersect each other at 0, 0. Now let's look at the dark gray graph. Here we have a curve here and a curve here. Now if you see, the dotted line is the vertical asymptote and this dotted line is the horizontal asymptote. Now the ordered pair that represents the intersection of these two asymptotes is going to be the h and k value of our transformed function. Okay, so what is the ordered pair that represents the intersection of those two asymptotes? Well, I can go to the left 1, 2, 3, 4, and then I will go up 2. So that means my ordered pair would be -4, 2. So now I'm ready to write the equation of the dark gray graph. It would be f of x equals 1 over, and it would be x Remember, this would be x minus negative 4, which is the same as x plus 4, and then plus 2. Now remember, when you write the h value in the equation, it always has the opposite sign as it does on the graph, because the formula is x minus the h value. So if your h value is negative, that's x minus negative, in this case, minus negative 4, which is the same thing as x plus 4. Now let's move on and look at the second graph. So in order to write this equation, I need to find the intersection of my two asymptotes, and I need to find the ordered pair that represents that intersection. And it looks like from 0, 0, I go over to the right 1, 2, 3, 4. So that means I'm going to have an h value of 4. And then I go up 1, 2, 3, 4, 5. So I have a k value of 5. So now I'm ready to write the equation. So for number 2, f of x equals, and that would be 1 over, or 1 divided by, x minus 4, and then plus 5. Now, why don't you pause the video and you try to come up with the equation for the third graph. Okay, so let's see how you did. I need to find the intersection of my asymptotes, which is down here. And so that means from the 0, 0, I would go to the right 1. So that means my h value is 1. And I would go down 1, 2, 3, 4. So I would go down 4, which means my k value is negative 4. So now, in order to write that, I have f of x equals 1 divided by x minus 1 minus 4. So how'd you do on that one? Now let's move on. Now, just like on the last page, the parent rational function has been sketched in with light gray, and that's just to help give us a point of reference while we're learning how to do this. Okay? First, we need to determine our h and k values so that we can determine the intersection of our asymptotes. So if I look at my first one, number 4, where it says f of x equals 1 divided by x minus 3 plus 2, my h value is positive 3, and my k value is positive 2. So that tells me where the intersection of my asymptotes is going to be. So I'm going to go to the right 3 and up 2, and there is my point of intersection for my asymptotes. So now I'm going to draw my vertical asymptote, and then I'm going to draw in my horizontal asymptote. Now I'm ready to sketch my curves. So here's my first one, and here's my second one. Now remember, these are just sketches that we're doing right now. They don't have to be perfect. Now let's look at number 5. We have f of x equals 1 divided by x plus 4 plus 3. Well, my h value is going to be negative 4, and my k value is positive 3. So this is the ordered pair that's going to be the intersection of my asymptotes. So I'm going to need to go to the left 4, 1, 2, 3, 4, and up 3. And hopefully that's somewhat accurate. Now I'm ready to draw my vertical asymptote. And now I'm going to draw my horizontal asymptote. And now I'm ready to sketch my graphs, or sketch my curves. So there's one, and there's the other. Now why don't you pause the video and try to do number 6. Okay, so how did you do? Well, the h value is positive 2 and the k value is negative 4. So that means the intersection of your asymptotes would be positive 2, negative 4. So here's the vertical asymptote, here's the horizontal asymptote, and then you can sketch your curve. Okay, now let's move on. Now we are going to write the equations for the vertical asymptotes and the horizontal asymptotes and then specify the domain and range. And we're going to do this without actually looking at the graph, just by looking at the equation. So let's look at A. We have y equals 1 divided by x minus 3 minus 2. We can tell the vertical asymptote by knowing the h value. And so in this first example, the h value is 3. So our equation for the vertical asymptote would be x equals 3. We can know the horizontal asymptote by knowing the k value. And the k value is negative 2. So the equation would be y equals negative 2. Now remember, at the beginning of the video, I said that the domain would be all real numbers, meaning it's from negative infinity to positive infinity. However, there is one exception. X cannot be the vertical asymptote, which in this case is 3. So x cannot equal 3. The range for a rational function is also from negative infinity to positive infinity. It also has an exception though, and that is y cannot be negative 2. And that's because y cannot be the horizontal asymptote. Now let's look at example B. Before we find our vertical and horizontal asymptotes, I want us to look at the numerator. Now remember, a negative sign in the numerator means that this graph will be reflected. And another thing to notice that because the numerator is not 1, it's a number greater than 1, 3, that means it will be steeper or it will be stretched. What I also want you to know about this numerator is that it has no bearing on the vertical or horizontal asymptotes nor the domain and range. We will do this just as if that numerator were 1. So for our vertical asymptote, what is our h value? Well, our h value is positive 2. So our equation would be x equals 2. Now let's look for our horizontal asymptote. What is our k value? Well, I don't see a k value. I don't see plus or minus a number after the fraction, which means our k value is 0, which means our horizontal asymptote is y equals 0. Now let's find our domain. Well, we already know that our domain is going to be from negative infinity to positive infinity, except that x cannot be 2. It cannot equal 2. And for our range, it is also going to be negative infinity to positive infinity, and y cannot be 0. Now, there is a lot more to learn about graphing rational functions, but I hope this lesson video has helped you with an introduction in learning the basics of graphing rational functions. I look forward to working with you again. Bye-bye.